work on solving more difficult trig equations. These are equations that are more difficult than the ones we've done previously, right? Previously we've done some boring ones where you say 6 sine of x equals 3, so I divide by 6, I get sine of x equals 1/2, and you say, oh, well, x is going to be, if sine is 1/2, pi over 6 and 5 pi over 6. Or if you were working in degrees, you would say x equals 30 degrees or 150 degrees, right? That's boring, and of course that goes on forever and ever and ever using our coterminal angles. Those are easy. We're going to do more difficult equations. We're going to jump right into it. This is going to use our trig identities, and we're going to do a lot of substitution, a lot of thinking using our minds. So the first one we're going to look at here, we'll call this number 1, is 2 cosine squared equals cosine of x. That's crazy. When can 2 times something squared equal just something? Let's find out. So the first thing I'm going to do is, hey, this is quadratic. What do we do with all quadratics? We get everything on one side and we try to factor. So I'm going to subtract cosine from both sides, and now I can factor a cosine out. So if I factor cosine out, I'm left with 2 cosine of x minus 1. So remember from algebra, our zero product property, or whatever you happen to call it, I have the product of two things and they equal 0. That means this product can equal 0, or this product can equal 0. So this one's already solved. I just need to finish it. And we're going to look for answers strictly between 0 and 2 pi. Okay, so we're going to look for them there. And let's say they can even be equal to 0. So when is cosine equal to 0? Well, cosine is equal to 0 at the top of the circle and the bottom of the circle. Top of the circle and bottom of the circle. This one takes a little more solving to do. I'm going to add 1 and divide by 2. So this is really asking when is cosine equal to 1/2. Well, cosine is equal to 1/2 up at pi over 3. And in the fourth quadrant at 5 pi over 3. So 4 solutions we get there. Easy peasy, up and easy. Let's try another one. Number 2, let's try one that's a little bit more difficult. How about we look at something like this? 2 cosecant squared equals 3 cotangent squared minus 1. And again, I know I don't say x's all the time here, but this is cosecant squared of an angle. It has to be of an angle or else it means nothing. So I look at this, I'm like, ugh, quadratic, let's get everything on one side, absolutely, but a little more difficult in the sense that I have 2 different trig functions. The idea is to have one trig function. Okay, right now, cosecant, I'm thinking of as a sine. Cotangent, I'm thinking of as a sine and a cosine. So I want to get rid of cotangent because that has 2 trig functions within it. So I think to my Pythagorean identities, I know sine squared plus cosine squared equals 1. And I know I get the other ones from dividing by sine squared or dividing by cosine squared. Since this is cosine squared over sine squared, I'm going to divide everything by sine squared, and I get 1 plus cotangent squared equals 1 over sine squared is cosecant squared. So I'm going to replace cotangent squared. I have 2 cosecant squared, which is really just a type of sine function, equals 3 times, now cotangent squared is the same as cosecant squared minus 1. Right? So cosecant squared minus 1. That replaced cotangent squared. But I still have this minus 1. Right? This whole thing is cotangent squared. Okay? So now what I can do is 2 cosecant squared, distribute the 3 cosecant squared minus 3 minus 1. Now I can combine like terms. I'm going to subtract this over here and get a single cosecant squared minus 4. Then I'm going to add 4 over here. Or I could factor if I want, but you'll see what I'm doing here. Couple options here, as there are oftentimes. Cosecant squared, remember, is the same as 1 over sine squared. Multiply. Divide by 4. And take a square root. Be careful whenever you take a square root, plus or minus. So this is saying to me, when does sine equal positive and negative a half? Well, that occurs in every quadrant at our pi over 6 reference angle. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And those are the 4 solutions we get for this particular problem. Are there always 4? Absolutely not. Are there 4 a lot? Absolutely there are. Okay, so be careful. Look for all solutions. Don't forget the plus or minus. Don't assume there's always 4, but always look for as many as you can find. Okay, so the idea is know your identities and use them to substitute out. Okay, get everything into one trig function. One trig function. And then solve it, whether it's factoring or just solving, but get everything into the terms of one trig function. Okay, and then try to get it into sine or cosine. You want that to be your final trig function. If you can't, no big deal. You guys know how to do cotangents and tangents and secants and cosecants, but if you can, get it in sine and cosine. And that's a little mini lesson on how to solve the more difficult trig equations. Have a good one.